All right, so we're going to continue on with our law of sines and our law of cosines. Today we're going to focus on law of sines. So remember that a triangle, the vertices are labeled with capital letters and the side lengths are labeled with the corresponding letter of the angle opposite them, but just lowercase. So capital A is across from lowercase a, and you get how that works. The law of sines is much simpler than the law of cosines. It's very easy to remember. It's a ratio, and it's just simply that the sine of angle A over side A equals the sine of angle B over side B, and that's also equal to the sine of angle C over side C. So you're not going to use all three of these at one time. If you know angle A and side A, you may use A and B. Or you may use A and C, or you might use B and C. You'll use whichever combination you need to get the question answered that you're trying to answer. So there's two times when the law of sine works really easily, and that's when angles are in the ASA pattern or the AAS pattern. So when you see a triangle that you either you draw it or you come across it and it's an AAS or an ASA, it's going to be a real easy law of sines problem. So let's start out with a quick example. So triangle ABC. So here's triangle ABC. Remember, there's no set way to draw these. I just draw them all the same way, so that way that I'm used to them being one way when I do my problems. All right, angle C is 102.3 degrees. Angle B is 28.7 degrees. And side B is 27.4 feet. And I don't know anything about the rest of it, but it says solve triangle ABC for the missing angle. So there's one angle right here we need to solve, and the sides. So real quickly, to find the measure of angle A, that's just going to be 180 minus 28.7 minus 102.3, right? Because this triangle has to add up to 180. I'm going to subtract the two angles I know and come up with angle A is 49 degrees. So I can go ahead and write that in there. It's going to make the rest of this easy. Now, let's do side A. To find side A, we're obviously going to use sine A over A because that's the one that has side A in it. And we're going to set it equal to either sine C over C or sine B over B. But since B is the one that we know both of, we know the angle and the side, we're going to use sine B over B. So sine 49 over A equals sine 28.7 over 27.4. I'm going to cross multiply, and I'm going to get A sine 28.7, and that's going to be equal to 27.4 sine 49. Then I'll divide both sides by sine 28.7, and I'm just doing regular algebra here, and I'm not even doing anything with the calculator yet. And so this would cancel, and I'm left with A equals, now all at once in my calculator, I'm going to do 27.4 sine 49 divided by sine 28.7, and get that A is approximately 43.1 feet. Okay, so that's how the law of sines works. Now we're going to use it to find side C, which is our last unknown side. So we could use our side A that we just found, but there's a chance that we made a mistake. So instead of using numbers we find, we're always going to try to use numbers that were in the problem. So we're going to use sine B over B again because we know those numbers are right. There's no way we made a mistake on those. And then we're going to use sine C over C to find side C. So sine B, sine 28.7 over 27.4 is equal to sine C, 102.3, over C. Cross multiply, I'm going to get 27.4 sine 102.3 equals C sine, I'm running out of room, 28.7. Divide both sides by sine 28.7. And I'm going to get that C is approximately equal to all in one time in the calculator, 27.4 sine 102.3 divided by sine 28.7. So C is approximately 55.7 feet. And a good habit for you to get into when you start working with all these angle problems is recognizing that of all the side lengths, 27.4, 43.1, and 55.7, this is the biggest. This is the longest. So this needs to be across from the biggest angle. So when we go back over and look at our triangle, we see that it is across from the biggest angle. And then 27.4, smallest, we see that that is across from the smallest angle. So that gives us a good feeling of confidence that we've done this correctly. If we came up with stuff that didn't make sense, a lot of times just by checking reasonableness of your answers, that's how you can find mistakes. So we're going to do one more example and then we're going to call it quits because this is pretty easy stuff. So instead of solve the given triangle, we're not going to solve everything. Let's just solve for side B. So we're going to solve for side B. Well, that tells us for sure that we're going to use sine B over B. But then for our other one, we're either going to use sine A over A or sine C over C. Now when I look at my picture, I see I have angle A, but I don't know side A. And I have side C, but I don't know angle C. But I really do, because this is 110 plus 120, that's 130. And the triangle has to add up to 180, so 180 minus 130 is 50. So I'm going to use sine C over C. So I've got sine 20 over B equals sine 50 over 25. Then I'm going to cross multiply and get 25 sine 20 equals B sine 50. Divide by sine 50. And again, I'm not doing anything. I'm going to type it all in the calculator, and that's it. So 25 sine 20 divided by sine 50 is approximately equal to 11.2 meters. All right, and that's the law of sines. That's the easy way. There's not much to it. Try to make this video nice and short for you, so enjoy and have a good evening.